I think I'll get started. Um, Good morning, everyone. I think I know most people in the group today. Um, yes, pretty much. There'll be a few stragglers, I'm sure. So look, thanks for coming along. Welcome. This is something I've wanted to do for a while, and I finally got it together to put something on. So yeah, today I'm talking about some Microsoft horror stories. I do know most people here, but for anyone that doesn't really know me, I'm Damien McLennan. I'm a freelance consultant CTO, software architect, and software trainer, and do software development and architecture training through my business, Stack Mechanics. I live in sunny Brisbane. It's pretty miserable today. And I have far too many hobbies: riding bikes, making coffee, playing guitar, driving cars, too many things. Um, Pretty exciting day on the bike front today with Mark Cavendish now breaking the record for stage wins in the Tour de France. I don't know if anyone's following that one, but that's a big day. Big day. Very happy. Spoilers. Yeah, sorry, Lorraine. If anyone doesn't know it by now. Um, yeah, sorry. Yeah, I checked Instagram at 5 in the morning and saw a spoiler, and it's like, oh no. Um, it's like April Fool's Day though. If it's after 11 o'clock, it doesn't count. Anyway, the agenda today is I want to sort of give a little bit of a background to this talk, and basically talk about um, some anti-patterns that I've seen and people see in microservices world, and the lessons and takeaways that we can learn from that. Then I'm going to get into a couple of just tips and resources and things that I've come across, and then sort of open it up to a bit of a Q&A and discussion. Cool. There's a few more people joined by the looks of it. Welcome, everybody. Cool. So some background on this talk. Essentially what I'm hoping to achieve today is share a lot of the lessons that I've seen out in the field. Hopefully everyone comes away having learned something, whether it's, some of the anti-patterns to look out for, some things not to do, some things to fix it, or even just, some extra ammunition, I guess. It's always nice to kind of see stuff that you've seen validated. So yeah, so hopefully everyone comes away with, having learned something useful. And I'd like to do something like this, something somewhat regularly, like quarterly or monthly or something like that, because I see a lot of stuff out in the world and I like being able to share these lessons. So I want to talk about a little bit about that at the end. So basically with my consulting work and training work, talks I've given, I talk about this stuff a lot. And so I see a lot of the same patterns and mistakes out in the world and really wanted to talk about them in a practical way rather than, a really snarky way. So a few months ago, I put out a call in a couple of places, some Slack groups that I'm in, put it out on LinkedIn, put out a call to people saying, hey, look, share some of your horror stories with me. And the internet definitely delivered. I got some good ones, and it was good to kind of cross-reference those with what I've seen, which was good. And so I took all of that and I grouped all the sort of common ones together, common patterns together, partly to anonymize it, and sort of to protect the innocent and protect the guilty, and basically distill it into, a set of anti-patterns and what they look like, why they happen, and what might a better option look like. And unsurprisingly, most of them come down to just poor domain modeling and context modeling, which is something I talk about a lot. We see a lot of people dive into software architecture from an architecture first point of view and really kind of miss a lot of the point. And I've given talks about this before. This is not a new thing to microservices. This has been happening as long as there's been new technology. Sorry, to quickly backtrack a little bit, I will get some Q&A at the end. So if you've got questions, by all means, save them up. But also, if you want to dump them into the chat, I'll skim through that as well. And we'll I've got one eye on it while I'm talking as well. So use the Zoom chat if you like. But yeah, definitely there'll be time for questions at the end and discussion. So yeah, with that as a bit of background, let's get into the anti-patterns, and I think I've come up with nine things, 9 groupings of all of this stuff. So here we are, number 1. This is the biggest one that everyone sees. This is it's got a few names: the entity service, service per entity, service per aggregate root, service per table, repository. It's basically, this is the number 1 trap that people fall into. And it's where people build and deploy a service that just holds on to some data. There's no real behavior other than just fetching the data out of the database and saving it back in. They basically become CRUD over HTTP. And this is really the sort of number 1 trap that people fall into, because these things get super granular. Sometimes it is literally just a table. And with that, the problem with these services, they can't ever really do anything useful by themselves. Yes, sorry, Ashley, this will all trigger a lot of PTSD for people. These services really can't do anything useful for themselves because they're not actually, they don't really have any logic other than potentially, a little bit of query logic and maybe some permissions. But because they can't do anything, we kind of get 2 problems that manifest out of this. And the first one is where you want to do something and you have to call multiple services multiple times to get all that data and munge it together in your calling service, decide how to join it, decide what to do with it, have any kind of matching rules there. And all of a sudden you've got responsibilities that have leaked all over the place. You've got responsibility for storing this sort of data over here and this sort of data over here, and you've got to figure out how to join that together in your and interpret it in your calling service. So you've kind of got responsibilities all over the place. And it's funny, the night before I announced this talk, somebody sent me this snarky tweet, which was microservices. What could have been a join is now 1,000 network calls. And this is what we see. It's just you want to do something and your calling service just has to orchestrate the whole thing. And it's just very, very inefficient. So that's the first kind of failure mode that we see from this stuff. The second one is, I think, worse, which is where you have a service that just has to make lots of calls to a dependent service, which calls a dependent service, which calls a downstream service. And you kind of end up with this synchronous chain of locks and latency and fault tolerance, all of the sort of problems that we see in a network application just exponentially expand. So, a piece of latency or a failure or an error in a downstream service just replicates all the way up. And we sort of, all of the goodness that we can get out of a distributed architecture or a microservices architecture around fault tolerance and, caching and performance and all these good things that we can get kind of go out the window because we just multiply network failures, many, many times. And this one is just super, super common. So some smells that we see around here is where we've got sort of retrial libraries, like in .NET land, there's Poly. And Poly is a great library for handling retries and circuit breakers and all of that kind of stuff. When you see people reach for that from the very, very beginning, that's probably a red flag that you've got these kind of network issues that you have to deal with. So that's the kind of first smell is, when that's the first tool that you grab, that's probably a problem. Another good one is when you have a whole service that's trying to manage referential integrity over HTTP. So before you can call that or before you can delete this service, you have to go check with another service to see if that's allowed. Or entity relationships over HTTP. I've seen one where basically relational databases were built on top of services on top of relational databases. So you would have to call an entity and then call a relationship service to find all the things that it had links to and then go fetch all of those things. This is our kind of distributed join over HTTP, where you sort of have other services to manage things that a database can do. It's probably a good smell. And the other one is service locators. So either in code, and I've come across code like this where you have like an HTTP service locator that's injected through all of your code where you can say, hey, I want a customer and I'm in production, and it gives you a URL to call from within, your service. That's probably a bad sign. That's a red flag. The other one is overuse of service meshes. We started to see a lot of that spring up when sort of 2019, 2020, when a lot of microservices stuff really, there was a lot of hype around it, a lot of traction. Everyone dived into Kubernetes, and then everyone needed a service mesh. And these service meshes basically got really, really smart and had routing rules and service location stuff because this stuff was so common. Yeah, mainly like Istio. And again, great product, great tools, but just became overused to do stuff that really shouldn't, solving problems that it really shouldn't have been there. So there are a couple of good smells where you see lots of this service location stuff in your code or in your architecture. Probably means that the stuff's just too chatty. So that's really the number one thing, or really like the number one anti-pattern. Number two is closely related, and I didn't name this one, but I love it. The conga line. And this is a really similar thing. We have these granular database services. But somewhere along the line, the dev team have kind of heard synchronous services calls are bad, async is good. And so they've kind of replicated this stuff, but using a lot of async messaging. So basically, you might have an HTTP request that comes into the front-facing service, and then it goes and requests the sort of downstream collaborating services. But the request is wrapped in like a Kafka event or something like that, and it continues down the chain. So each caller is waiting for the downstream service to return data, over a Kafka event, and it's just sitting there spinning and waiting. And at the top, you've got the calling service waiting for all of this stuff to bubble back up, but it's over messaging rather HTTP. So a failure in a downstream service doesn't end in, the HTTP request timing out or throwing a 500 and the error chain bubbling up. Just nothing happens. So everyone's just sitting there waiting. So now everything waiting is in this really unknown state. So again, this is our boundaries not being right. The receiving service, or sort of the top level service, should be able to do what it needs to do and return directly to the client or to the caller. So, if it needs to send commands and publish events for downstream services to act, great, that's fantastic. But it shouldn't need to wait for a response until it, comes back to the client. So sometimes there are long running processes. So the best thing that you can do then is kind of save a record of a job or a transaction or whatever it is with a pending status, and then return to the caller quickly with, a URL to poll, for that status. And then, you've got to wait for a bunch of downstream services to bubble up events, you can catch those and, mark the job or transaction as complete when it's done. And that's a much more scalable way of, and reliable and fault tolerant way of building that sort of thing. Because then you can have some compensating action to say, look, the downstream services haven't responded within some time-based SLA. What do we do now? So that's the conga line, just waiting for something to happen. So anti-pattern number 3 is the third drawer. You've got that third drawer in the kitchen where just all of the bits that you don't have a good spot for live there, and you can't open it anymore. A lot of people have talked about services like this, where you have some deployed instance of a service that's just a mishmash of unrelated features and functions and stuff that no one could figure out where to put. And this one came up a couple of times, and there's kind of two main culprits of this. One is sort of an infrastructure concern or a build pipeline concern, where it's just too much work or mucking around, sort of headache to deploy a new service. So we've got this thing, it's too hard to create a new service. So we'll just stick it in here. You kind of end up with that third drawer, that junk drawer of stuff. So it's potentially a problem with how your CI pipelines are set up, whether you've got some outsourced or external DevOps team that you need to go to be able to deploy a service, and it just becomes too much work. So potentially problems just around your build infrastructure. Or the other one, and this is kind of related, we've got services that are just for data, like we talked in sort of pattern 1 and pattern 2, and no one knows where to actually put behavior and functionality that spawns, that sort of spans multiple services. So it just goes, oh, look, we need to put this somewhere here. It talks to everything. Let's, stick it here in the third drawer because we don't have a better spot for it. So the solution to that is modeling. Again, if we've got services that better own the behavior, then that's the spot to put that stuff. Number 4, and this one is related, is the conductor. So this is some functionality that often shows up in the third drawer as the result of something like the conga line service, where we've got a bunch of async stuff that never returns, but sometimes that's a service by itself as well. So basically this service type is orchestrating behavior. It's orchestrating business processes, moving data across services and stuff like that. By itself, not a massive red flag. There's a really common pattern called a saga pattern, which is about maintaining the state of a process or a transaction. So when I was talking about the conga line, I mentioned like a simple example of you've got a long-running job, request comes into the service, it saves a thing to say, hey, I've kicked off this job, it's pending, fires off commands and events to downstream stuff. And when all of the completion events come back in, you can kind of mark it as processed. Think about a transaction waiting for a credit card payment to be processed. Once that payment comes through, it gets marked as complete, we're all good. That's a saga pattern. It's a good thing. But in a well-modeled system, that saga is a business process and behavior that's kind of owned by a service that owns that business process. So the red flag is where you've got all of these sagas and kind of process monitoring stuff that live, in the third drawer because there's no other, there's no other spot to put them. That's anti-pattern number 4. All right, anti-pattern number 5. When the deployment order matters. So this one's a giant red flag. And if this one came up a bunch of times and I've talked to people and I've seen it a lot of times, and it's when you've got a microservices architecture or distributed architecture and everything needs to be deployed in there's a few comments. I'm not shaming anyone here, Andy. We're not playing bingo. Yeah, when everything has to be deployed exactly at once or exactly in the right order, it's a bad sign. And it's a sign that everything's entirely too coupled. If you've got a database change that goes in and that needs a bunch of different changes to HTTP contracts, and they needed to be immediately effective across multiple services because they're not backwards compatible, there's a sign that your boundaries aren't correct. There's just far too much sharing. Coupling is way too tight. And that's it. That's instant red flag. Another really fun example of this I've seen a long time ago in a sort of SOA environment. There was a lot of Windows services. There was something called a service manager, and it controlled the order that services would start and stop. So if you wanted to do a deployment, you would need to call the service manager to shut stuff down in the right order, redeploy, and then start the service manager and restart everything in the right order. And it's because if a service started and it couldn't see one of its dependencies, it would just crash or get into a broken state and everything was bad. So you had this service manager that controlled the startup order of everything. And that was a bad time. That was a really bad time. So this one's super common. Long time ago, when it was a much smaller company, I worked for Octopus Deploy, and I'll never forget a support ticket that came in saying Octopus doesn't support microservices. And it was because it couldn't guarantee that everything got deployed exactly at the same time. So yeah, this one's super common, and I see from the reactions that we've all seen this one. We've been burnt by this one. Huge red flag. All right. Yeah, that's it. A change required to one service before others doesn't seem a big deal. You've got more than race conditions. Yeah, often it's where you've got, Robin, where you've got sort of message contracts and HTTP contracts and DTOs that change a lot and often. And we've kind of got this very tight coupling where everything depends on, having exactly the same records. Again, because we're kind of joining across multiple services, you kind of need that all out there. All right, number 6 is flaky build and deployment stuff. Now, this is not unique to microservices architecture by any means. We've been plagued by terrible build and deployment processes forever. So this is not microservice specific. But if you don't have your act together on this, you will absolutely exponentially exacerbate the pain. You need to have streamlined, consistent, documented way of building and deploying the application. And it needs to be maintained. So a couple of fun stories. And I know from the group, a few of you will recognize some of these. Looking through one of them, somebody here contributed to one of them, and somebody else was around for it. If each developer has their own shell scripts. Thanks, Ashley. Yeah, so one of this is entirely like that. So a couple of fun things that I've seen out in the field and other people have told me about. Some good ones is infrastructure as code. So like a Terraform or a Pulumi or something like that, that has been done without an external kind of cloud-based or whatever based runner. So you have infrastructure as code, but your deployments get run from one developer's workstation that has, API keys set as environment variables and whatever. But to run an infrastructure change, you don't necessarily have to have that code pushed to source control. And that's horrible if you have inherited that, because you don't know when you're running it if the last person has run a bunch of changes and never pushed that code. So you've kind of got that moment of, I'm rolling out an infrastructure change, but I don't know if the code I have matches what's in production. And that is absolutely terrifying. So that's a massive one, is if your IAC isn't run from somewhere kind of nominated. Second one, and this is a story that was shared, where you had a dev lead basically had a cron job on their machine, and it just pushed whatever was in main at the end of the day to an EC2 instance that only they had the keys to. And it wasn't documented, no one else had the keys. And basically, they pushed a bunch of broken code, I think after lunch on a Friday, and then took off early for a long weekend. And of course, at 5 o'clock, this stuff gets rolled out and everything goes to pieces, and they're not around to fix it. That was a good story. People have scars from that. I've seen a startup that outsourced all of their DevOps to a third-party agency. So whenever they wanted to release a new version of their code, basically they had to call somebody and say, hey, can you build my Docker container and deploy it to AWS? That's going to give you a bad time. SaaS-based CI tools that quietly make breaking changes. And it's probably the only time I'm going to do it in this talk. I'm going to name names. This was Azure DevOps, and this was me, and I lost days to this. So basically they're, long-running code base and quiet breaking changes, and all of a sudden the pipeline UI would just crash. And the only way to fix it was opening it up in like their classic editor and saving it again, which kind of flushed out some state, and then it would work again. And then we had a bunch of devs leave the team and their tokens expired, so the builds would fail. And that's good, normal, expected behavior. You want that. But then because it couldn't connect to the source control because the token expired, the UI would just crash with an AngularJS error. And so the only solution was to delete it and start again. But the new pipelines had a bunch of different defaults around things like Git checkout depth. So a lot of our Git version stuff would start crashing. And all of the logging was zero usefulness. So it was just like Googling, bunch of troubleshooting, heaps of guesswork, and it just cost us days. And it was just because, just a platform that just quietly made breaking changes without really publishing them. So you need to trust your tools. And then another one, and this is kind of less of an issue really, but this is just something I come across as a consultant, is a mix of new and old tools. So, I'll create something with new versions of Terraform or build tools, and then something breaks or you need to make a change, and, something's on an old version. So you just need to use this constant cycle of just keeping stuff up to date. All right, so that's number 6, our flaky build and deployment. Number 7, the failed refactor shantytown. Again, this is something I come across a lot as a consultant. You see this a lot in companies that have a high staff turnover, and you kind of do a little bit of archaeology in there, and you can kind of see attempts at, we're going to refactor this to whatever new pattern, and then the company's priority shifts and they never get finished. And eventually the people get frustrated and move on. The cycle continues. New people come in and go, well, this is a mess. Let's start again. If you're in this situation, you want to tread very carefully, because you're going to find refactor or rewrite. Again, like, full rewrites never succeed. If you walk into a company that looks like this, full rewrites never really concede. You never have time, again, because they got like this because the priorities shift so quickly. So if you step into this, there's going to be time bombs and landmines everywhere, and you'll see those things come at you in combinations and clusters. Stuff like, synchronous blocking calls to an HTTP service that can hold a transaction, but that service actually just a wrapper around a database table, because it's an unfinished idea, and it was probably a shared database. And then you find that sort of dependent service has a certificate that expires because everyone forgot about it, it wasn't documented, or it stops working because it's on an outdated runtime version, and you're on a PaaS provider and they deprecated that version without warning, and then you can't rebuild it because the build pipeline service failed for that reason. Like, hours, days of downtime if you walk into this stuff where there's just unfinished attempts at services everywhere. Yeah, that's a bad time. And several people have several horror stories about stuff that looks like this. All right, number 8 of 9, the shared database. This one came up a lot when I put it out there. Everyone jumps on this one. Microservices, by definition, should have their own data store. But the shared database comes up a lot in people's horror stories. To me, this one's a red flag. It's not an instant death sentence. It's possibly a symptom of just bad infrastructure automation, or siloed teams. Yes, Tom, MongoDB's web scale. So if you've got like a DBA team that controls everything and they've got a 3-week wait time, you see there's a lot in big companies where it's just too hard to make a new database. And people go, well, I need to ship my stuff. There's a database, I'll dump it into them. So often you see this not as a result of bad design, but it's just siloed teams, hard infrastructure, again, CI systems that are just hard. If you get into that, a lot of people say like using separate catalogs or database namespace is an option here if you've got no other choice. So it's kind of logically siloed, if not physically. It's also possibly a sign that you really didn't need that service in the first place. So again, going back to the failed refactor, we've got a service, but it's from the same database tables that we already had. The silver lining on this is having a shared database has come to the absolute rescue of a lot of projects and absolutely saved them at the last minute when they're starting to get close to production and it's just running horribly slow, again, because we've got a distributor join doing 1,000 network calls and it's just awfully slow. The number of times that this has happened where right at the last minute, someone's gone, let's just write a stored procedure that just joins all the tables, and bang, our API is really, really fast again. So the shared database has absolutely been the savior of an awful lot of projects. All right, and last but not least is the log hunter. And this is when you have absolutely no idea what your services are doing until the customers ring. Again, not specific to microservices, but in a distributed system, this multiplies and will absolutely exacerbate any problems that you have. I know of more than one large company that did large microservices rollouts and didn't think about their instrumentation. And when something went wrong, they would be SSHing onto a cluster of servers and grepping log files across all of the services to try to find out what was going wrong. Again, hours of downtime or outages. So you absolutely need to bring in some form of structured log aggregation, distributed log aggregation, metrics, You need to be able to really quickly see patterns in response times, error rates, service health, and then be able to dive into logs across instances to track down problems. You need to be able to visualize it. You need to be able to graph it because the logs are coming at you way too fast. Like you can see a screen full and miss errors. And you probably shouldn't build this yourself. Go find a vendor, buy it. I'm a big fan of Seek from Datalust, Brisbane company, for a lot of things I work on, but New Relic, Datadog, Honeycomb, App Dynamics, there's a handful of them, all options, but you absolutely need to have this one. So yes, if you walk into a microservices architecture and they're relying on log files or just standard out from Docker containers, you have big time bomb on your hands. Okay, so they are the 9 sort of common patterns that came out of all of this. And really there's 2 main big lessons that come out of it. The first one is modeling is absolutely the most important thing. Think about your service design. Think about and understand the role of a service and have it own that role. It's, responsibility principles. This service owns this business process. That is the guiding principle of SOA 25 something years ago, and the guiding principle of microservices. And it just got lost. So modeling is absolutely important. Understand your behavior of the business. So these kind of data services that just own a table are never going to work well. They're never going to scale well. You need to model services around behavior, and there's a lot of techniques to do that. There's like event storming, there's event modeling, ways of modeling, understanding the business behavior and the service behavior and business processes, and model the services around that. Understanding what needs to be synchronous and what can be asynchronous, and don't cross those streams. Super important. So, all of this, most of those anti-patterns can be solved just by good modeling. And then the second big lesson is be on top of your infrastructure. So you need good instrumentation. You need a snapshot of the health of the system. You need log aggregation so you can dive into your logs as you need it. That log aggregation needs good correlation so you can trace transactions across business processes, requests, transactions, that kind of thing. To do that, you really need structured logging so you can, index on fields, and you can find all the events for a user ID or for a transaction ID or even a client, see what's going on by getting more meaning out of your log message than just a line. So structured logging is absolutely needed. Automate your pipeline, your build pipeline. Have that standardized. Pin things like build images, Terraform module versions, build tool versions, SDK versions. They will break. If you've got build pipelines and they're pinned to Windows latest, that canon will change, and dependencies that were there will not be there. So absolutely pin versions so that you can trust your pipeline. Particularly in services, if you've got a big architecture and a small team, there will be services that you don't need to deploy every day. And they're the ones that when you need to deploy them, that's when you don't want to find out that your build process doesn't work anymore. So, test your builds, run nightlies, that kind of thing. Good infrastructure as code that's understandable, documented, and that anybody within reason, with permissions, can run the things they need to do. Again, don't let things go stale. SDKs, runtimes, build tools, pipeline, and choose platform that is stable, where you understand when it's going to change. So they are the 9 anti-patterns and the big lessons out of it, which was really interesting to get all of the sort of feedback from people and understand it and kind of correlate it with my experiences as well. So that's it. Now I'm going to dive into some resources and things that I found in my travels. The first one is, it would be remiss of me to not mention that I do training on a lot of these things. On the Stack Mechanics website, I've got some courses, can do some custom training. I've changed the shape of these a little bit. It was sort of a 3-day thing. I've now broken it down to small pieces of 1-day courses. They can be in-house, they can be remote. I can split them up remote because 8 hours on Zoom is awfully tedious. And I'm also 80% committed to the idea of doing an online sort of monthly cohort model of training for individuals. If they're of interest to you or anybody, please get in touch. I'd love to hear from you. Next resource is, I think in the room, he was there, Ashley Davis, who is a Brisbane-based developer, has brought out the second edition of this book, Bootstrapping Microservices, with Docker, Kubernetes, GitHub Actions, and Terraform. It's out through Manning Press. And it's great. Getting started on sort of a modern microservices stack, if you've come from an older way of doing things, there's a huge bunch of things you need to learn at once. Again, like new build processes, Docker, infrastructure changes, a whole bunch of stuff. And Ashley's book's a really good practical kind of walkthrough of all of those tools, how they work together and how you can get up and running. It's got my name on the back of it too. That's cool. Ashley and I actually recorded a conversation about this for GoTo Conference, have a sort of chat with the author segment on their YouTube channel. So Ashley and I had a big chat about a lot of this stuff a few weeks back, and it will be online soon. I'll let everyone know when that is. So check that out. Next one, and this is something that every time I mention it gets a lot of interest, and I put up a little throwaway LinkedIn post the other day and people loved it, and it's about the Pomodoro technique. And that's about, and there's a website there for it. It's about I'm using a timer to do short bursts of really intense work followed by a short break. And it's kind of time boxes. And it's a really handy technique for focusing on tasks, particularly for me, because I can get distracted, sort of focusing on this. And I put up this little LinkedIn post the other day and people really related to it because I bought this new timer that has a 25-minute work block and a 5-minute break block. And I got it to replace this timer, which just had the work block. This is cool. So yeah, every time I mention that, people get really, really interested in it. So I thought I'd mention it. And the last thing that I've come across recently that is super interesting is a new documentation IDE from JetBrains called WriterSide or Writer's IDE. And it's basically the JetBrains IDE shell. So if you use Writer or IntelliJ or whatever, it's basically that. But inside it is a writing tool for doing technical documentation. So it gives you the writing environment with a table of contents and a static site generator and templates for exactly what you would want to see from product documentation. And it will even sort of pull in Swagger Docs and generate API documentation for you and then publish it. I've not done much with it other than poke around, but I think it's really interesting and really promising. And I desperately need to write a bunch of documentation for Nimbus, which is my message bus library for .NET. So I'm probably going to use this. So I'll talk about it some more, but if you're struggling with getting good, consistent documentation, this looks like a really useful tool. So that is the end of my resources. And we have 17 minutes. So I'm going to throw it out there for a few minutes to see if people have questions. Should microservice deployment be part of your IAC or separate? I'm going to throw the it depends answer out there. Jonathan, so there are a bunch of ways to deploy microservices. Definitely the underlying infrastructure should be. I've worked with a couple of patterns that I like. I quite like using Terraform to do Fargate. I have a standard Terraform module that I use for Docker that I can pass in all the variables, and through convention, we'll set them as environment variables. And then I will either use, I like Terraform Cloud a lot. just because it gives a lot of the locking and audit trails and logging and stuff like that. And you can easily use the variables in Terraform Cloud to set versions, or I will have a JSON file in my environment code base with the versions of stuff. So I quite like that pattern. The other pattern I've used a lot is use ISC to manage the underlying infrastructure, and then use some other deployment orchestration tool like Octopus Deploy, so I can kind of see what versions are in what environment. So they're two that I've used. They both have their quirks. Yeah, like Andy says, it does depend on the resources and the size of the environment. Andy's in a much bigger environment that I'm working in at the moment, so it would be very, very different. Yeah, it depends.
Funnily enough, we deploy almost the same as you. CloudFront and CloudFormation instead of Terraform, but it's very similar.
Yeah. Yeah. Okay. Interesting.
It's actually a lot simpler.
Yeah, cool. I've used Octopus a lot for sort of, the old way of deploying iOS sites to Windows Box, and Octopus does a lot, and they're going all in on Kubernetes. I will use it to orchestrate Terraform, which feels a little bit like a sledgehammer to put in a thumbtack. But from a workflow, it's really good. It's really nice to go, there is a new version, promote it to prod, just press the button. It calls, a small script underneath, does a lot of the secrets management. It's quite good. Yeah, I've not found Utopia yet. Ashley, you've got your hand up.
Yeah, thanks, Dave. I
Question?
mean, that was really awesome. I really enjoyed that. I want to go back to point number 2. I think HTTP requests versus async messages, and let's just set aside that async messages are obviously really good for sending notifications and triggering kind of like cascades of behaviors in other services. Let's just put that aside. Is it a smell to use an async message to do a request for data and get the response as another async message? Is that always a bad idea, or have you seen cases where that's actually legitimate?
It's not always a bad idea. It has some gotchas in that they can, if you've got good code so that it looks like a message that you are waiting, so that looks like a sync. And the problem is you're taking a synchronous thing and putting it over an asynchronous transport. So you need to have timeouts. You need to throw failures when stuff goes wrong. It's like it can work. You have to do a lot of work to make sure that as a message comes in, you knew about it going out. Which, if you are clustered, you need to keep a track of message correlation IDs and reply to IDs. So you then need to, if you've got multiple services listening to that message, you need to do work to make sure that it recognizes the reply that comes in, rather than going, well, I didn't send that, I'm not going to reply to it. There's a lot of gotchas. It's just kind of using the transport for something that it wasn't designed to do. Can work. I've used sparingly. It's fine. It's when that is a really common pattern and you've got a big chain of it, you're just kind of cascading that ability to fail. And it's a red flag, because if people are doing it, they've probably not thought through all the implications of doing it. And then just kind of end up with these just lost messages all over the place. Does that answer the question?
Oh, sorry, I forgot to unmute. Yeah, no, that was great. Thank you.
Yeah, cool. All right. Question: when deployment order matters or things can be deployed, don't crash the dependency. What are some of the approaches seen here with dependencies not yet available? Cool. So this is a question about when the deployment order matters. So two pieces there. Generally, and again, this is a generally, it matters, the deployment order matters more where your coupling is too tight. So if the modeling is wrong and the coupling is too tight, it matters a lot more, because you've got these long contracts, like API contracts, and they need to match. And if they need to match all the services at once because our coupling's all wrong, then that's where the problem is. So some other approaches, yes, retry entitlements. Again, these are all good techniques. In general, if your modeling is right, it happens very, very rarely. It might be 2 services, and then you can go, let's deploy that and then deploy that one. It's not a everyday thing. It's where every deployment has to be in exactly the right order that you have real problems. You are going to have times, even with good modeling, where, you know, deployment order of maybe 2 things matters a little bit, particularly if you've got some migrations and stuff. But a good approach, if that really happens, is use versioned APIs. So you can have, like, if you know you have to release a big breaking change, you can have your old API that behaves the same way as it did, have a new version of the API that does the new thing, and then write some code. So if something calls the old API, rather than it being processed on the old path, it gets captured, whatever transformation and data munging that needs to happen so that it's compatible with the new way, and then just run backwards compatible APIs side by side for a little while. And once everything's stable and your deployments happen, then you can deprecate and turn off your old API. That's a better approach if you have genuine breaking changes than just kind of retrying a bunch of times until everything's come good. Certainly safer. Would the versioning of API flow through new versions of the message? Okay. So Robin's question was versioning APIs in a message bus situation. This is one of my favorite ones, because a lot of people ask me about this, which is versioning contracts in messages. And my general answer to that is, if you've got your modeling right for behavior and you are publishing messages, those messages should be events about some business process or transaction that has happened. And generally, those things are going to be very semantic. So we have a new customer, or this order was just successful, or this payment was just successful. And generally, those messages are quite small. And I have very rarely seen it where you've needed to put out breaking changes in those messages. Where there have been breaking changes, it's something like we had one property that got turned into a collection of properties. So, you know, there was one thing and now it's an array of things. And then you just have side-by-side properties. It's actually really rare that you need versioned message contracts when you're dealing with events and commands, because they're quite small. There are times, but generally, you know, and in that case, you can just send 2 side by side, or just have properties and have the receiver go, oh, this uses the old property or this uses the new property. So you just have to do a little bit of backwards compatibility thinking in your stuff. But yeah, it's one of those things that everyone's worried about. And I've actually seen it be an issue not a lot of the time. Anyone else? If your model has holes, I'm sure. Yeah, look, absolutely. And there's a lot of this comes back to modeling. Absolutely. Question, I feel like a typical app customer wouldn't need a microservice architecture. Most app. Cool. What's the tipping point? Okay, so I'm going to read this again. I feel like a typical app or customer wouldn't need a microservice architecture. Most apps don't have the load demand or scaling needs. Do you have any rule of thumb test or tipping point at which you'd be reaching for a microservices versus a modular monolith? And this is a great question and I love it. And Ashley and I talked a lot about this in the podcast we did actually. So I agree. A lot of most really successful microservices architectures, most, you know, asterisks, came from a monolithic application that worked until it hit some challenge, whether that was a scaling challenge or a caching challenge or whatever. And like a lot of the really early case studies for microservices were successful businesses that hit challenges and then went, this bit's painful, let's break it off into a service. And people doing greenfields microservices architecture without experience in doing microservices architectures are the ones that kind of generally end up in these sorts of messes. So no, the advice for most teams would be build what you need, solve the problem you have today, and then break it up if you hit issues most of the time. There have definitely been projects that I've kicked off and gone, well, this makes sense. One of them was a compliance, medical compliance type environment where we knew that we needed to tick a whole lot of compliance boxes, and to be able to say, we can break this up. So we've got really large SLAs around these pieces, but these pieces over here that don't have privacy concerns, we can deploy more freely and sort of build internal tools. And using messaging, we could strip out things like PII and personal data from services. So breaking stuff up from a compliance and privacy point of view was absolutely the right choice. Some things you definitely do know, and at the outset, you're going to have scaling. If you've got data that doesn't change very much, find some way of separating it. But again, a lot of the times you've got a monolithic app and you go, this bit's getting hit a lot. Let's break it out. So yeah, the tipping point for a team that's not experienced, I would definitely say get it working first. If you do have experience enough, you can kind of look at it and go, I know this is going to be, or again, if you design for, things like compliance and privacy, there's some good tipping points. Or again, if you've got a toolkit of, I can just roll this stuff out because I've got the build tools and I've got the build pipeline and I've got, all the Terraform, it becomes very, very easy. But in general, I would start with a good modular monolith and then break stuff off of it. Wrap it up fairly quickly. One more question. Talked about refactoring the shantytown. Obviously, a lot of refactoring that failed, and rewrite's not the only way. What would your approach be in the situation? That is a much bigger topic. And a lot of the thing is, some of the ideas in that refactoring the shantytown are good. They just never got finished because of organizational problems. I do have a lot of patterns up my sleeve for refactoring legacy systems into microservices, but that's a day in itself. Yes, good automated tests, absolutely. All right, I'll wrap up questions there. I do have a quick ask from me to you. Basically, I would like to do a tiny bit of market research, but I don't need people to answer now. I'd love to hear from people here what their thoughts are on a lot of this stuff. And to make it easier, I'm going to send out a quick survey. There's only a handful of questions in it, and I would be incredibly grateful if you could take 5 minutes to just put some answers in there, as little or as much detail as you want, for some questions. So I've got a couple of things in my mind. First is this a valuable thing? And would this be a more valuable thing as a more regular thing? Is this format of, here are some lessons that I've seen and here are some useful things I've seen in that, is that useful? Or would a more sort of open discussion, office hours, question and answer kind of thing where people can bring their questions and problems, we can workshop it in public, or is that more of a private thing? So I've got questions about that because I would love to do something like this regularly, and I'd love to find out what's valuable. Second one is, training budgets for people are tight at the moment, but there's a lot of lessons that people need. So I've got some questions around how to best get this knowledge out to people. I've got courses. Am I missing the mark? So again, I'm not going to ask it now, but shortly after this, I'm going to send everybody a quick survey. There's like 6 questions in it, and it's anonymous, and I would be super appreciative if you could spend a couple of minutes and put some stuff in there. It would be amazing. So with that, with 2 minutes left, thank you very much. I've had a great time. I've really enjoyed it. I hope people here enjoyed it. I hope it was useful. I hope you learned something. Definitely. Lots of thank yous. Amazing. Thank you. Yeah, I really hope you found it useful. Answer the questions. If people would like it, I will do this again and again and again, because it's fun. So with that, thank you very much for spending an hour with me on a windy Thursday, and I hope to see you all again soon. Thank you so much. Bye.